the quadratic formula. I'm sure many, if not most of you, have seen the quadratic formula before. What you might not have seen before is, where does it come from? The quadratic formula is nothing more than a special case of completing the square. So I'm going to take the equation ax squared plus bx plus c, and I have to have a cannot be 0, because if a is 0, the x squared goes away and it's not quadratic anymore. And I want to solve that equation for x. All right, so how did we do that? How did we solve by completing the square? What was the first thing we would do when we had a number here and a number there? Minus the c. The first thing we did is we took this number and we moved it over. So I'm going to do that. So I'm going to write this as ax squared plus bx equals negative c. What was the next thing we did? What did we do when we had a number right in front here? We divided by that number. Why did we divide by that number? You need an x squared by itself. You've got to have a 1 for that number there. So I'm going to divide everything by a. Once again, as usual, when completing the square, we have fractions. We have x squared plus b over ax equals minus c over a. Lots of fractions to deal with. Next, we added our magic number. How did we figure out our magic number? We take this thing in the middle, which is b over a. We divide it by 2, and then we square it. So I'm going to take b over a. I'm going to divide it by 2, and then I'm going to square it. And I'm going to do the same thing we've done all along. I'm going to think of the 2 on bottom as 2 over 1. I'm going to flip and multiply. That's b over a times a half squared. So that's b over 2a, whole thing squared. So that's b squared over 4a squared. There's my magic number, if you will. Got a lot of letters in it this time. All right, so it looks a little ugly right now. It's going to get better, trust me. So we're going to have plus b squared over 4a squared. Plus b squared over 4a squared. If I did everything correctly, the left-hand side should factor like that. What should go in my parentheses? X plus b over 2a. Why plus b over 2a? That was right, what we had right there, right before we did the squaring. When you complete the square, the number that goes here is always the number you had right there, right before you did the squaring. Now, this mess over here, I'd really like to have a common denominator. So what I'm going to do to get a common denominator is I'm going to take this fraction on the left and I'm going to multiply top and bottom by 4a. How does that help? If I multiply the bottom by 4a, what's 4a times a? It's 4a squared, isn't it? All right, so this, I'm going to write this left-hand side as minus 4ac plus b squared over 4a squared. All right, and I'm just going to do one little simplifying thing here. Left-hand side, I'm not going to do anything. I'm going to leave it as x plus b over 2a squared. The left-hand side, I'm just going to reverse the order. It's usually written as b squared minus 4ac all over 4a squared. Just reverse the order there. So if you know the quadratic formula, you might be starting to see part of it come up here. If you remember the quadratic formula, it's got a b squared minus 4ac in it. Okay, what's next? Square root on both sides. On the left-hand side, I get x plus b over 2a On the right-hand side, I'm going to write it as plus or minus the square root of b squared minus 4ac. But down on bottom, I can do some square roots. What's the square root of 4? 2. And what's the square root of a squared? It's a. So down on bottom, I just get a 2a. Finally, how do I get the x all by itself? Subtract the b over 2a. So x is negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. But as normal, I notice, heck, look, I've already got a common denominator. So I'm going to write this as one thing. I'm going to write it as x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and that's known as the famous quadratic formula. Questions on that? So most times, when you have formulas, especially a formula that big, I mean, that's got quite a few letters in it, quite a few symbols, people think that the formulas just came up from some magical occurrence. And I always like to show this one to show that it's really not a simple magical occurrence. It came from something you knew. It came from completing the square. When it comes to taking a test, will I make you go through all these steps to show me the quadratic formula? No. What will I do on the test? I won't give you the formula. You're going to have to go home and memorize it. But what I will do is I will ask you to do something like this. The directions will be solve 3x squared minus 4x minus 1 equals 0 using the formula. That's the sort of question I will expect you to be able to answer. I don't expect you to be able to derive the formula. I expect you to be able to use it. Well, the formula is very nice. Let me ask you a question. If I said solve using completing the square, would you be real happy with me? You shouldn't be. Why not? You're going to have to divide by that 3, which means you're going to get lots of fractions and you're going to have to deal with them. Are those fun? No. But if I say solve using the formula, you should be pretty happy, because your answer will be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You'll memorize the formula, and you'll write it down like that. And then all you have to do is plug in the numbers. What's b? B is negative 4. B's got a minus sign in front of it. So b is negative 4. So what's negative b? Positive 4. 4 plus or minus the square root of. What's b squared? Negative 4 squared is 16. Minus 4 times, what's the a number? 3. What's the c number? Negative 1 all over 6. So that's 4 plus or minus the square root of. Let's see, 4 times 3 times 1 is 12. And then I've got 2 minus signs, so that's going to make a positive. 16 plus 12? 28. Over 6. Was that easier or harder than completing the square? A whole world easier, in my opinion. Ah, very good. When you go to take your test, as far as I'm concerned, that's a perfectly correct answer. You can leave your answer just like that. However, when you go to do your work on my lab will not accept that answer, because my lab will want it simplified. Can you simplify the square root of 28? Yes, how can you simplify square root of 28? 4 square root of 2? No, I don't think that's quite right. You got the right idea, though. 28 is 4 times 7, and the square root of 4 is a nice number. The square root of 4 is 2. So this is going to be 4 plus or minus 2 square roots of 7 over 6, because 28 is 4 times 7. The square root of 4 is a nice number. And then everything is even. We got a 4 there, a 2 there, a 6 there. We divide everything by 2. So if you're doing your work on MyLab, you're going to be required to write it as 2 plus or minus square root of 7 all over 3. Again, I personally won't care. When you go to take your test, I will be perfectly happy if you leave your answer just like that. Like I say, MyLab is fussy. MyLab's going to require you to type that in. Questions on that? All right, let's try another one. Solve. Give me some numbers you like. Got any good numbers?
5x squared.
5x squared.
Plus 3.
Plus 3x.
Minus 6.
Let's make it plus 6.
Plus 6.
Equals 0, just to be different. All right, well, here comes the hard part. The hard part with quadratic equations is we have a lot of different ways to solve them. What are the different ways we can solve quadratic equations? Square root method. Completing the square. Factoring, and the quadratic formula. We have 4 choices. And this is what makes quadratic equations hard. If you want to solve a linear equation, there's only one way to do it. You do all linear equations exactly the same. You get all the x's on one side, all the numbers on the other side, and then you divide. For quadratic, you've got 4 different choices. Which way do you like for this problem? Completing the square is nasty because you're going to divide by 5. You're going to get lots of fractions. Quadratic formula, I think, is the only realistic way to go. Factoring is going to be pretty nasty because I'd have to take the 5 times the 6 and get a 30. That's pretty nasty. I don't want to deal with that. The square root method doesn't work because we have an x squared and an x. My opinion, looking at this problem, I would say I'm jumping right to the quadratic formula. I'm not even going to try anything else. So here I go. X equals negative b. What's negative b? Negative 3. B is the number 3, so negative b is going to be negative 3. Plus or minus the square root of, what's b squared? 3 squared, which is 9, minus 4 times 5 times 6, 4 times a times c. All divided by 2a, and 2a is 10. So there's really the only downside of the quadratic formula. You've got to memorize it. To be able to use it, you've got to memorize it. There's no other option. In other words, go home and memorize it, is what I'm saying to you. I will not give it to you on the test. I will expect you to know it. All right, we simplified just a little bit. That's negative 3 plus or minus the square root of, I'm going to use my calculator here a little bit, 9 minus 4 times 5 times 6 is negative 111 over 10. And we should do one little thing. What's the one little thing we should do? We don't write negatives under square roots. We take that out and it becomes an I. So I would write this as negative 3 plus or minus I square root of 111 over 10. And I don't think the square root of 111 reduces at all. So I think that's okay. I think we can leave it just like that. Questions on that? All right, the last couple things I want to talk about here before we do some other problems. X equals negative b plus or minus square root b squared minus 4ac all over 2a. There's your famous quadratic formula. And I find it interesting that I tell students to memorize that, and almost everybody will memorize that. That's good. But then I ask students, what's the formula for vertex? Which I think I also told you should memorize. Negative b over 2a. Excellent. Somebody remembered it. What I want you to notice is that formula for vertex is part of the quadratic formula. So if you know the quadratic formula, the formula of a vertex is just part of it, negative b over 2a. So don't forget about that formula either. So once you have one, you have the other. The other thing I want to talk about a little bit is this part of the quadratic formula called b squared minus 4ac. b squared minus 4ac is called the discriminant. What does the word discriminant mean? Well, it's very similar to the word discriminate. What does the word discriminate mean? I know you all know what the word discriminate means. What does discriminate mean? Somebody give me a definition of discriminate.
Like a textbook definition?
Sure, like a textbook definition. To not include something, usually based on some sort of characteristic of the thing. All right, so what I want to point out is, when you're dealing with this, b squared minus 4ac discriminates the kind of answers we get. What happens if b squared minus 4ac is a positive number? What happens if b squared minus 4ac is a negative number? And what happens if b squared minus 4ac happens to be 0? The middle one's the easiest one to answer. What happens if b squared minus 4ac is a negative number? Well, that means we're going to have a negative underneath our square root. What happens when you have a negative under your square root? You're going to get two imaginary answers. I can't spell imaginary, so I'm going to call them complex. So that's why we call it the discriminant. It discriminates the types of answers you get. When b squared minus 4ac is negative, you get a negative under your square root, you get complex answers. What happens if b squared minus 4ac is a positive number? What happens if you have positive numbers under your square roots? What kind of answers do you get? You get real answers, don't you? You don't get complex, you get real. So you would get two real answers. And this one's kind of the weird one. We haven't had this happen yet, but it can happen. What happens if the thing under the square root happens to be the number 0? Well, if the thing under the square root happens to be the number 0, what's the square root of 0? 0. So up on top, you're going to have negative b plus or minus 0. What's negative b plus or minus 0? It's just negative b, isn't it? So your answer is going to be negative b over 2a. So what's going to happen? You happen to get one answer, and the answer happens to be the vertex. That doesn't happen very often, but it can. And the way it would happen would be if your equation was something like x squared minus 2x plus 1 equals 0. If I gave you that equation, how would you solve it? You really should factor. Will the quadratic formula work? Absolutely, the quadratic formula will always work. Always, for every problem, the quadratic formula works. Completing the square always works too. It's just harder. But this one, if this first number is the number 1, you should really try factoring. And that factors that way, x minus 1 squared. You only get one answer, x equals 1. So that can happen. Take it and plug it into the quadratic formula if you want. You'll only get one answer, I promise. All right, the last thing that I really like about the quadratic formula, from my standpoint, Your calculators are not only graphing calculators, they're also programmable. So if you happen to know a little bit of computer programming, you can sit down and write yourself a program for the quadratic formula. And I happen to have one that I wrote a number of years ago. What it asked me to do is it asked me to put in A. So this problem that we did a minute ago, A was 3. Put in B. B was -4, and C was -1. And my calculator tells me the answer is 4 plus or minus the square root of 28 over 6. 4 plus or minus the square root of 28 over 6. And then my calculator even goes ahead and gives me decimal approximations. Now, you probably don't have that program on your calculator. But if you have a little programming skill, there's something you can do. You can program in that quadratic formula. Questions on that? Yes?
Can you just put it in like on
Sure.
what you'll obviously have to put the first one?
Right, so I can show you a little bit what my program looks like. Now, my program is better than most. Most that I've seen, let me just put these numbers back in again. Most programs that I've seen, they don't give you the exact answer. They just give you the decimal approximations. That's not too bad. But, I mean, the way it looks, if you want to see it briefly. Clear the home. Input A, input B, input C. So type in the numbers. If A is 0, stop. How come if A is 0, you just stop?
Because it's not a quadratic.
Because if A is 0, it's not a quadratic anymore, is it? It's linear. All right, so that was just a little thing. Then I went and determined B squared minus 4AC, and I called it D. Why did I call it D? Because it's known as the discriminant. Why did I have the calculator figure out B squared minus 4AC? Because then I knew if I was going to have complex numbers, or if I was going to have real numbers, or if I was going to have one answer. So if D is 0, you only get one answer. If D is positive, then you got to tell the calculator how to get the two answers, and then output the answers. And then way down later here, I've got if D is negative, then give the complex answers. Anyway, my program is much more complicated than most. Like I say, most programs just give you the decimal approximations. I wanted to be able to have the exact answer. I also wanted on my calculator for it to give me complex numbers if the answers come out complex. Most programs that I see don't give the complex answers. It just says, it just crashes because it tries to take the square root of a negative number. So mine has a lot more fancy stuff in it than what you really need, but that's what I wanted, so that's what I did. So you can go online, and I'm sure you can search for quadratic formula program TI-84, and I'm sure you can find some, and you can sit down and you can copy them and type them into your calculator, and you can have your own formula. Probably easier to simply memorize it and just write it down on paper to do it for on the test.
Would you be able to write your own code if you know how to do it?
Sure. Yeah. And if you know the coding, if you're familiar with computer programming, the calculator uses a form of BASIC. If you've ever programmed in BASIC before, go ahead and do it yourself. All right, so I'm not going to solve these because I don't have time today to do all these. What I do want to talk about, it says solve using any appropriate method. So as we talked about a little while ago, we have 4 different choices. We can factor, we can complete the square, we can use the square root method, we can use the formula. Looking at this first problem, which method would you use? Completing the square would be pretty good. Completing the square would be pretty good because this first number is a 1, and this middle number is even. Why is completing the square nice when this number is a 1 and this number is even? You're guaranteed you won't get any fractions. So completing the square would be pretty good. I don't think that would have been my first choice, though. If this first number is the number 1, I usually try to factor first. Because when this first number is the number 1, factoring is usually pretty quick and pretty easy. Is there any way to split up 15 to get a 6? No, turns out it doesn't factor. But I would have tried that first anyway. Pretty quick and easy. And then after that, I agree with you. Completing the square would be pretty good. Would the formula be pretty good? Yeah, the formula is always pretty good. But completing the square wouldn't be a bad way there. How about B? Again, I would try to factor. Can I split up 28 to get a 3? Yes, how? 7 and 4. So that one I would definitely factor. Would completing the square work? Yes, but I'd have to deal with fractions. Would the formula work? Yeah, but I think it's a lot harder. If this first number is the number 1, factoring's better. How about C? I would jump immediately to the quadratic formula. When this first number is not the number 1, I don't want to factor. It's a pain in the neck. I also don't want to divide by 5 and have all those fractions to complete the square. That one's definitely a quadratic formula problem. Completing the square would work, but it's hard. How about D? Quadratic formula would work, but I think it's a bad idea. Because in order to do the quadratic formula, I'm going to have to take this thing and I'm going to have to FOIL it out. We went through this just a few minutes ago. What did I tell you to do whenever you see a parenthesis like this with a square? Square root method. So what you want to do is move the 24 over and then divide by the 4 and then do square root. Quadratic formula would work, but you're going to have to FOIL this out, then you're going to have to distribute through by the 4, then you're going to have to combine all your like terms. It's a lot of work to get there. But it would work. But this one, to me, I look at this, I see the parenthesis with the square. This one is absolutely a square root method. Not that other ways won't work, but I think square root method is your best bet there. It's the easiest way. All right, the problem I want to do, I'm going to skip number 2 because I don't have time. We'll just look at number 2 very quickly. Find the vertex. How would you find the vertex? We would use the little formula x equals negative b over 2a. Determine the y-intercept. How would you find the y-intercept? Let x equal 0. I can do that one easily enough. When x equals 0, y is negative 5. I just plug 0 in. How would you determine the x-intercepts? Set y equal to 0. So you're going to have 6x squared plus 12x minus 5 equals 0. How are you going to solve that equation? Again, I would look at that equation and I would jump immediately to the quadratic formula. When this first number is not the number 1, I go ahead and use the formula because it's going to be at least as quick as factoring is, in my opinion. So I might as well just do it. Because if I try to factor, it might not factor anyway. So I would jump right to quadratic formula. All right, and then you would plot those points and draw your graph. What kind of picture are you going to get? It's going to be a parabola because it's got an x squared in it. All right, number 3. A person throws a stone into the air. The height in feet, h of t, after t seconds is given by h of t is negative 16t squared plus 52t plus 4. Find the h-intercept. How do I find h-intercept? Means the other letter is 0. If I ask for h-intercept, the other letter has to be 0. So that means t equals 0. H would be, I plug 0 in, I like doing that. That's easy. 0 plus 4, that's 4. So my t-intercept would be the point 0, comma 4. Explain the meaning, or I'm sorry, my h-intercept. Explain the meaning of this point. What does that mean? Well, t is 0. What's t again? Time in seconds. So at time 0, the height of the stone is 4 feet. So what does that mean? When I threw the stone, it started 4 feet in the air. So a kid was throwing the stone up in the air, and his arm was 4 feet high. So stone was thrown from a height of 4 feet. Part B, find the t-intercepts. How would you find the t-intercepts? Set it equal to 0. You want h to be 0, so minus 16t squared plus 52t plus 4 equals 0. How would you solve that equation? I'm going formula, absolutely. T equals negative b, that's going to be negative 52, plus or minus the square root of 52 squared. I'm going to use my calculator. 52 squared. Calculator says that's 2704. Minus 4 times a is negative 16 times c is 4. All divided by 2a. 2a is going to be negative 32. All right, so that's negative 52 plus or minus square root of 2704. Minus and a minus is going to be a plus. 4 times 16 times 4. Calculator says that's 2960 divided by negative 32. Unfortunately, the square root of 2960 is not a nice number. But I think in this problem it makes sense to give a decimal answer. I want to know t is going to be time. I want to know about how many seconds it is. So I'm going to take my calculator and I'm going to type in negative 52 plus the square root of 2960. And then I'm going to divide by negative 32. So one answer is t is negative 0.075. And then I've got to do it again. Negative 52 minus the square root of 2960 divided by negative 32. The other answer is t is 3.325. All right, and then it asks, what do those mean? Well, I think one of them doesn't mean anything. Can't have negative time, so we cross out this one. Time can't be negative in this problem. So what does the t equals 3.325 mean? That's when the stone hit the ground.
You didn't throw it very far.
You didn't throw it very high.
Yeah, high.
Very high. Stone hits the ground in 3.325 seconds. That doesn't seem like very long, but I challenge you to go home and take a stone, throw it as high as you can in the air and see how long it takes till it hits the ground. I bet it's not very long. I'd be willing to bet you'd have a hard time having a stone be in the air for 5 seconds, in fact. 5 seconds doesn't seem like very long, but try it. Determine the vertex. How do we find the vertex? T equals negative b over 2a, which is going to be negative 52 over negative 32, which is 1.625. And then I'm going to take 1.625 and I'm going to plug it into my formula here. So negative 16 times 1.625 squared plus 52 times 1.625 plus 4. Each would be 46.25. What does that mean?
Reach the height.
This 46.25 is the highest the stone goes, and it reached that at that time. So stone had maximum height of 46.25 feet at 1.625 seconds. And in this case, it is important, since it's a vertex, that you have the word maximum in there. If you just tell me the stone reached a height of 4.625 feet in 1.625 seconds, you're missing a little bit of information there. It is important to tell me that it was a maximum. Part D, I don't have time to finish, but all you would do with Part D is you would take negative 16t squared plus 52t plus 4 equals 30. And then you would have to solve that equation. How would you solve that equation? Do what? Subtract 4? I would actually subtract the 30. Why would I subtract the 30? Because then I have it equal to 0, and then I can use the quadratic formula. Again, I'm looking at that negative 16 out front. I don't want to complete the square. So subtract the 30, and then use the quadratic formula would be my answer.